Assalamu alaikum everyone, and today we are going to talk about inverse trigonometric functions. In these few videos, we've been going through the 6 trigonometric functions, how to graph them, and some other calculations regarding trigonometry. Today, we're going to look at inverse trigonometric functions. Now, I know what you're thinking. Isn't cosecant the inverse of sine, and cosine is the inverse of secant, and tangent is the inverse of cotangent? Yes, I know that, but that's not what inverse functions are. That's like inverse proportionally, but here's like an inverse function. Put this, you will understand what if you just stay here and watch, then you'll understand more. So an inverse function, if you're not familiar with, let's give an example on how it works in algebra, at least. Let's say we're trying to find the inverse function of y equals to square root of x. We swap the y's and x, and now we solve for y. And y equals to x squared is the inverse function of y equals to root x. But it's not a random function. If we, let's say, put the square root of 16 as 16 is a value of x, we get y equals to 4. 4 is the answer. Now if we put this into our new function, we get back the number we started with, which was 16. So this is how inverse function works. Like when you solve something for y, by giving a specific value, the answer with the new inverse function will be the value you put. But not all functions have inverse function. Like their graph has to pass the vertical line test, you know what I mean? To verify that it is a function. Now a trigonometric example for this is y equals to sine x. First we swap the places, then we use the inverse sign on both sides. Now the inverse sign is a new trigonometric, you can say function, which, totally cancels out the sign. Remember, the inverse sign is not the same thing as 1 over sine of x, or sine of y for this case, because of the fact that would mean that this is a cosecant, but this is not a cosecant. So if we in a calculation say in the inverse sign of cosecant, it would not cancel each other out. It will not be the doubled answer. You know what I mean? Now, canceling this out, y's new function would be the inverse sign of x. Remember, we put the y back once we solved for y, which is this one. Basically, there's one more thing to talk about, which in functions clearly gives the way that inverse sine is not equal to cosecant kind of thing, is that in a function, normally in the y equals to sine x function, x is the corresponding, x is the angle that you put in, theta, and y is the corresponding value of sine. And in the inverse sine place, it's quite the opposite. Y is the corresponding angle and x is the sine value. This can be important later on. Sine can also be represented by, inverse sine can also be represented by arc sine. So if you're using a scientific calculator and get confused where inverse sine is, that's it. Okay, so remember that in inverse functions, in any inverse function, it has to pass the horizontal line test of its original function. Like this is the original function and we need to pass the horizontal line test. If it passes, then we know that this specific graph has an inverse function. Now, it reflects that. So, a total reflection here, and it has to pass the vertical line test to see if the function or the graph we found is a real function. I know we already verified that here, but again, we have to verify that it's a function. This only verifies that it has an inverse function graph or sketch. But this one verifies that it is a real function. You can look at my what are functions video if you don't understand the vertical line test or the horizontal line test. And some of my graphing videos in my algebra playlist. I'll try to leave a link in the description or up in the cards. We can easily see, and I mean easily see, that a sine graph doesn't pass the horizontal line test in an infinite way. It's a periodic graph, come on! It'll obviously have more and more points. But if we restrict its domain of sine x up to negative half pi and half pi, suddenly we get the sketch that has an inverse. So this is basically a graph of sine x, but it's restricted up to negative half pi and half pi. Now reflecting across x, we get this and vertical line test, and boom! This is the sketch of an inverse sine graph. Nearly. This also tells us how. Now, if we say an example like, what is the inverse sine of square root of 2 over 2? Now, for these examples and questions in your question paper or your test, you absolutely need to memorize the unit circle. And I have a video of memorizing the unit circle, which can be linked up in the cards or in the description below. You just have to look at it. So in the unit circle, we can see that pi over 4 is the sine that gives sine value, that the angle that gives square root of 2 over 2. Why can't I memorize this? So, and just like we said earlier in the video, we can go back, like going from sine of pi over 4 to literally the square root of 2 over 2, because we literally just said it. So that's how it verifies that it's the inverse function. A cosine graph is very similar, but we have to restrict its domain up to -1 and 1. And its range up to 0 and pi. And the only domain and the values is going to be -1 and 1. I know how fast I said that. And in a tangent graph, which before we get into, let's do an inverse cosine function. Yes, we have inverse cosine and inverse tangent. Basically all the inverses. Even inverse cosine and all that. We'll learn more about those things though later on in this series. If we say what is the inverse cosine of -1/2, then the answer according to the unit circle would be 2 pi over 3. And that we can even do it reverse. Now let's get to tangent. The one that my brain can't wait for, trust me. Although when I edit this, I probably will cut the whole mistakes, but as I'm recording this, it took me a long time. So if we restrict it to only half pi and -half pi, its domain will be restricted up to -infinity and infinity. Reflecting that, we get pretty much a graph of all real numbers in the x-axis, which in the y-axis is -half pi and half pi. The heights of these or the values of y, but whatever. And a question for tangent. What is the inverse tangent of square root 3 or root 3? This one is a little trickier. We can use sine over cosine y as in equal to root 3, and we can solve for root 3. Now root 3 over 2 and 1 over 2 will be equal to root 3. Doing some math, we can see that the answer would be pi over 3. With that, we've quite understood almost everything we need to. Now, not in your class mostly, most probably you won't have to evaluate all of them one by one. And if you're someone who calculates something like stellar parallax or some scientific thing that needs trigonometry, you can always use a scientific calculator so that it doesn't eat all of your time. But if you're in a school and you're not allowed to use this, don't use this and memorize this. But you can use a scientific calculator if you want. Here, I can just, what you have to do is set up the mode. Like in my scientific calculator, I can just press shift and this button, the setup and mode, and set the mode to radians, and then just shift, sine, and whatever we want to put here. I'm just putting a random number, and it will usually give a messy answer, which you can just use to STD button. And here, that's a little scientific calculator tutorial, semi-tutorial for you guys. And with that, that's all there is to it. You can subscribe to my channel for more of these basic, well, not really basic when it comes to trigonometry, but just algebra and trigonometry and organic chemistry. If you're interested in these sort of areas, remember to subscribe. And also more are coming, like physics is coming near after trigonometry, so remember that. And you don't want to miss out on physics because that will be a whole lot more fun. So since you won't miss out anything, you can subscribe so that you don't miss out anything. And you can like the video, you can share it to other people who have confusions in similar fields. And that's all there is to it. Thank you for watching, and I will see you next time.